Well, hello everyone, friends. Today we have a chiller, an SNA industrial chiller, model CWUL20. This model is actually designed for 20-watt machines. It also functions as a heater, meaning a heater or a hater, right? And a cooler. So it's two in one, maintaining a stable, standard temperature. Today we'll quickly take it apart to see what's inside. We'll do a quick run through of the internals. There are a ton of screws around the perimeter for a regular screwdriver. We won't need anything else here today besides a screwdriver. And we'll also figure out how to fill it with water. I'm going to fill it with distilled water, just regular reverse osmosis water, without any fancy stuff. I know people will start writing to me now saying that I need some super antifreeze, or some super, I don't know, ethylene glycol, or alcohol, or this or that. Actually, there are many options for what you can pour in here. You need to understand clearly that this chiller will be kept indoors where the temperature is more or less stable, so we won't have freezing or extremely high temperatures. That's why distilled water will be more than enough. The only thing I might add is a couple of drops of something like Domestos. Now, some hater will write again that this is, damn it, it's sodium, caustic soda, or some alkali that will corrode the pipes. Yeah, it's quite likely that it will. The chiller and everything else will be ruined. But as we know, nothing in this life lasts forever, so let's start with the simple stuff. Again, a couple of drops for this volume is only to eliminate the high probability of forming some kind of mold or moss that would grow in this water, so there are filters on both sides. Again, they're designed for air intake to cool the radiator section directly. It's all plastic, but there's a mesh, so we'll wash it periodically. What do we see here right away? The water tank is covered with this kind of insulation or soundproofing. The tank is quite large. There's absolutely nothing written here about the tank's volume. So the volume is unclear. It says something about the filter, that it needs to be cleaned every 15 to 30 days. So there's info about the filter. On top, there's an instruction manual for the control panel. We'll deal with that separately. And we can see the pump right away. Let me get a screwdriver and we'll finish taking it apart. The nameplate shows exactly how to use the manual and our display. The connections in the connectors themselves. Our GX16 by 3 connector. The inlet water pipe goes straight into the tank. The outlet water goes through the pump and through the motion sensor, pressure, flow, whatever you want to call it. The GX16 by 3 connector itself, 220 volt power. 2 QR codes for service and the manual, an indicator tube that just runs through here. Actually, there's more. There's nothing here. The fans, there are two of them here, 220 to 240 volts, 0.22 amps, ball bearings. Well, basically, it seems pretty good. It says there's some special protection here, so it's the same on both. Information, drain valve, serial number, a nice holographic sticker, and the instructions, or industrial water chiller. A little manual on how to fill it, top it off, and all the other details. So, model CW5200AI, there's some kind of CV code. Voltage is 220 to 240 volts, Freon R134A, frequency range 50 kilohertz, 50 hertz. So the Freon charge volume, 180 grams, maximum pump pressing, meaning the max pump pressure is 25 meters. Well, 25 meters, that means upwards. So the pump itself pushes 2.5 kilograms. The weight of this unit is 24 kilograms. Next, current consumption from zero point 0.4 to 6 amps at 220 volts. We calculate that the average value comes out around 1.2 to 1.3 kilowatts. Tank capacity is 8 liters, so basically 2 5-liter jugs will be more than enough. Nominal cooling cap is 1.43 kilowatts. Don't forget that here, well, regarding the current, it's a very interesting point, but here we have both a compressor and, accordingly, a heater. And if they work together, then it turns out we'll have 1.43 kilowatts. So we can't say exactly how much the compressor consumes, so most likely there's a heating element for a kilowatt here, maybe, or maybe a bit less, though probably a kilowatt. And the rest is the consumption of our compressor, plus the fans, plus the pump itself, and everything else. Made in China, Website teyu.com China, Guangzhou Teiyu Electromechanical Company Limited. Well, everything's as clear as can be here. Yeah, let's take a look at one thing right away. There's the same filter on the other side. We also pull it down. All the elements are completely plastic, so more or less UV radiation will lead to the total destruction of your. Well, let's be real, the plastic's going to be screwed. So all the elements are plastic. How long they'll last, who knows, but that's how it is. Same thing, the tank is covered, the tubes are all covered. Access to the control module is closed here, probably to avoid getting dust, debris, and condensation inside. There's a seal on the top part. The seal is only between the body and the tank neck. But what it's for, I more or less understand. Why there's no seal here, who knows? Well, classic, basically. We take the cover off upwards. We've unscrewed all the bolts. In theory, nothing should be in the way. Excellent. So, a quick look at this layout. Two powerful cooling fans. The radiator. The radiator's likely 99% certain made of aluminum, though it's quite possible it's copper. It's already a bit beat up from the factory. Well, I get that people work here, not robots, but actual people. So it'll be a bit dented and scuffed. That's just a plain fact. The compressor, what do we have here? The solenoid for the open close valve and the evaporator chamber itself. So it's all pretty standard here. There's nothing else really extraordinary here. Here's a pump on the backside. So as far as components go, the most we have is this power supply, mounted separately on top, likely for the control panel. No, it's not even for the panel, it's for the pump. I'll show you what the connector looks like now. Again, the 3-pin GX16-3 connector goes straight to the panel. It just plugs into the relay. So it's a simple relay, 3 leads, either this way or that way. So, well, there aren't really any other options there. Moving on. Again, why did I take it apart? Because this relay isn't secured at all. Not even a bit. I'll have to clamp it down now. On one side and then on the other. So the unit that's, well, nicely made, which protects all the electronics, sits on the tank. I mean, there's a gap right here where you can fit a whole hand. Let's take a close look at the other side, and then we'll do a quick walk around. Okay, again, what do we have on this side? A capacitor. Again, a capacitor. Either a starter for the compressor or who knows what it's for. To repeat, the pump. The pump is powered by the power supply, either 12 or 24 volts. It's bolted on, but there's no info on it at all, so it's a no name. Okay. The drain neck leads to a pipe for level indication. So we have a level indicator here. It's usually just a tube run through some plastic thingy that goes to the top of the neck. So basically, the bottom drain or bottom pipe is for both drainage and indication. Nothing more. They siliconed everything. Good job. No doubt about it. Again, 2 fans, the radiator. There's likely some silica gel here. And it goes to the evaporator. I mean, through this little capillary tube. It's all as simple as can be. Next, the pump doesn't draw from the very bottom. It draws from about 6 centimeters above the tank floor and pushes it to the right outlet pipe. The outlet, the exit, there's a flow sensor right here, so naturally, without that flow sensor, this whole thing won't work. The return line is just a regular hose that simply runs back into the tank. That's it. And here are the outlets for the 2 pipes. The Freon outlet also goes through the oil separator. So it's strange how they've done it here. The outlet tube goes to the compressor through the oil separator for some reason. Maybe I'm just missing some. But anyway, whatever. Wait, I might be wrong. No, it's correct. Actually, who knows? Here we have that wonderful Chinese quality again. So let's look at it from this angle. The control unit is covered by a separate pipe, which is pointless because there's a huge gap here. Basically, that's the whole chiller for you. The only difference between them is the radiator size, the number of fans, The pump power, tank capacity, and the compressor itself. The compressor is some GCCN 118NO model. It uses R134A Freon as per usual. I have no idea what the model is. I mean, there's a label, but it's completely uninformative. The most it says is that it's a 220 to 230 volt compressor, 50 to 60 hertz. That's it. That's all we've got. No power rating or anything else is listed. So essentially, that's the whole chiller. As for how much it actually costs, who knows? I can't give you an exact figure because the prices vary everywhere. Different factories make them differently. Prices are all over the place, plus shipping, weight, and dimensions. But there are models for 5 watt, 10 watt, 15 watt, and 20 watt machines. We got this one specifically for a 20-watt machine. Again, this provides both heating and cooling. Inside the tank itself, there's a heating element that warms the water if the temperature drops below a set level, and it heats it up to whatever upper threshold we've configured here. Then the compressor kicks in, and it starts working in the opposite direction. So the temperature is constantly fluctuating up and down like this. The advantage of having large tanks or reservoirs is that they act as a buffer, storing a specific temperature. This means that any temperature drops or spikes, depending on how much your machine heats up, happen more gradually. So it really comes down to what kind of machine you're using and for what purpose. Is this chiller used for CO2 lasers? If I'm not mistaken, I don't think it is. But in theory, if your CO2 machine is in a room with sub zero temperatures, or say close to zero, then I think a chiller like this would be a real workhorse because condensation will form on the tubes. It'll form on the mirrors too, so you'll need to heat the water. You'd set the lower and upper limits to, say, 16 to 20 degrees, and it will maintain exactly that range. So, as always, a thumbs up from you, and for me, a big wish for everyone to wake earlier, go to bed later, and work, as they say, a bit more. Well, it's about 6 in the morning now, I think, and we're continuing our fun day today. That's it. Peace and prosperity to everyone. To everyone. Bye bye.